Hello, welcome back. To continue our analysis of strategic situations in game theory, we're going to have to introduce a concept that most of you, unless you've taken a game theory class before, are probably not familiar with, but that plays a big role within game theory. So one thing about strategic situations is that when you're in a strategic situation, sometimes, for example, think that you're playing rock, paper, scissors, you have to think about what your opponent is going to do. And to figure out, for example, do you think that your opponent is going to choose rock, paper, scissors? And if you've been playing for a while, maybe this is 5 out of 9, and you played 3 or 4 games already. You might want to think, is next time my opponent going to play rock, paper, scissors? And in order to think about that, you might have to think about what your opponent thinks that you're going to play. And then going one step forward, you could in principle think about what your opponent thinks that you think that your opponent is going to play, and so on and so forth. And this kind of reasoning may actually be important for games and for strategic situations, and that's what sometimes can make the analysis of games a little bit tricky. But anyway, so one concept that turns out it's very useful is to think about what are called hierarchies of beliefs or hierarchies of reasoning, which means precisely this. It means when you're thinking about what the other person is thinking about what you're thinking, and so on and so forth. And these things play an important role. So we're going to introduce a concept related to hierarchies of belief, which is called common knowledge. And I would like to start with an example. This is a classic logic puzzle, which you can find on Wikipedia or on the internet if you want to read more about it. And this is a logic puzzle, and imagine you have 3 logicians, Anna, Bob, and Charlie. And these logicians, they always speak the truth, and they have unlimited reasoning abilities. And they are sitting in this room, and they know that they are wearing hats, and their hats are either blue or red, and everybody knows this. Um, and each of them can see the hats of the other 2 logicians, but this is a room without mirrors, so they cannot see their own hats. So Anna can see that Bob has a red hat and Charlie has a red hat, but Anna doesn't know whether her hat is blue or red. Similarly, Bob can see that Anna has a blue hat and that Charlie has a red hat, but Bob cannot see that his own hat is red. And Charlie can see that Bob's hat is red and Anna's hat is blue, but she cannot see her own hat. Okay, so this is the situation, and this is going to be our starting point. And then somebody asks the logician in order, what color is your hat? So this person asks Anna first, and Anna says, well, I don't know, I cannot see my own hat, so I know that it's either red or blue, but I don't know which color it is. So this person then asks Bob, and Bob gives the same answer. I don't know, it's either red or blue, but I don't know which color it is. And then finally, this person asks Charlie, maybe this person is called David, asks Charlie, and Charlie also says, I don't know the color of my hat. Okay, that's a simple enough situation. So let's complicate things a little bit, just one tiny little bit. So now suppose that David tells them, well, I don't know if you already knew that, but let me tell you that at least one of you has a red hat. Okay. So now David gives them this additional piece of information. However, this is the cool thing about this story. This new information that David tells them, it's something they already knew. Anna could see that Bob has a red hat and Charlie has a red hat. So Anna already knew that at least one of the 3 of them had a red hat. Bob could see that Charlie had a red hat, so he already knew that Charlie had a red hat. And Charlie could see Bob's hat, so Charlie already knew that Bob had a red hat. So when David tells them one of you has a red hat, David is telling them something that they already knew. Okay? And then David proceeds again to ask them one by one, what color is your hat? So if this is the first time you're listening to this puzzle, If you really know this was a logic puzzle and therefore there must be a catch, I think that the normal intuition for most people would be that, well, if you tell them something they already knew, this should make no difference. However, there will be a difference, a big difference. So he asks Anna, what color is your cat? And Anna will say, I don't know. Yeah, so she doesn't know. Then Bob is also going to say, I don't know, because knows, Bob can see that Charlie's hat is red. So Bob doesn't know, if Charlie's is the only red hat in the room, or if Bob's hat is also red. But then Charlie says, oh, my hat is red. Of course my hat is red. So telling, and we'll see how he figured that in a minute, but so telling them something that they already knew actually changed things, actually made a difference. So let's see what's going on. So what happened after the announcement? If Charlie's hat had been blue, then Bob would only see blue hats, and since Bob was told that there was a red hat in the room, he would have been able to infer that his own hat was red. So I'm sorry. If Charlie's hat was blue, then Bob would only see blue hats, so he would be able to infer that his own hat, Bob's hat, was the red one. Okay. So if Charlie's hat was blue, when David asked Bob what color is your hat, Bob would have said, of course my hat is red. Because Bob didn't say that, Bob revealed the information that he was seeing at least one red hat. So Charlie knew this, and Charlie knew that Anna's hat was blue, and therefore Charlie was able to conclude that his own hat was the red hat that Bob was seeing. Okay. Now notice that it's crucial for this story that Charlie knew that Bob knew that there was at least one red hat in the room, and that's where the heart of the situation is. Before the announcement, everybody knew there was a red hat, but Charlie didn't know whether Bob knew or didn't know that there was a red hat. Yeah. So when David made the public announcement, there is at least one red hat in the room. Yes, he told everybody something that they already knew individually, but before the announcement, Charlie didn't know that Bob knew that there was a red hat. After the announcement, Charlie knew that Bob knew that there was a red hat. So the difference is that by making this public announcement, it wasn't just the case that everybody knew that there was a red hat. After the announcement, everybody knew that there was a red hat, and everybody knew that everybody knew that there was a red hat. And that's what we call second level of mutual knowledge. And that's something that's going to play an important role in game theory. Okay, so let's look at a perhaps simpler example, maybe a less interesting one, but one that might be easier to follow. So three logicians walk into a bar. The bartender asks them, "Does everybody want a beer?" The first one says, "I don't know." So by that he reveals that he does want a beer, because otherwise the answer would be no, not everyone wants a beer. The second one says, I don't know, which means that he also wants a beer. And then the third one could say something like, okay, so we'll have 2 beers and a Pinot Noir, or whatever. It's a glass of wine or something, a scotch. So yeah, so part of the story of the three hats is that um, by um, is that people can learn about what they know and don't know. But the other part of this puzzle, the part that is relevant for me today, is to explain to you the difference between everybody knowing something, what everybody knows, and whether everybody knows that everybody knows it, and so on and so forth. Okay. So when everybody knows something, so if in the original situation in the three hat puzzle, everybody knew that there was a red hat, we call that situation mutual knowledge. It's mutually known among the logicians that there is a red hat. when everybody knows, and everybody knows that everybody knows. So the way it happened after the announcement, that we say that we have second order mutual knowledge, that that some event is true. In the case of the three logicians, that there is a red hat. That's not where things stop. You could ask whether everybody knows that everybody knows, whether everybody knows that everybody knows, and everybody knows that everybody knows that everybody knows. In which case we would say that we have third order mutual knowledge. And you could have fourth order and fifth order and as many orders as you want. And I'm going to link this video. It's already on OWL. This is a video clip of Friends, a sitcom from the 1990s called Friends, where they create a funny situation exploiting this level degrees of mutual knowledge between a secret among a group of friends. And when when everybody knows that everybody knows that everybody knows, when something is mutual knowledge and second order mutual knowledge and third order and fourth order and all the orders of mutual knowledge, in that case, we say that it is common knowledge. Okay, so a fact is mutually known if everybody knows it, and it is commonly known if everybody knows it. Everybody knows that everybody knows it. Everybody knows that everybody knows it, and so on and so forth ad infinitum. Okay, so that's common knowledge. The way to think about common knowledge is it's about public. It's something that's public information. It's something that's truly public. It's something that it's not just that everybody knows it. It's that we all know that we all agree, and we all know that we all know that we all agree, and so on and so forth. So it's a very strong notion. Um, Perhaps it's stronger than we need, but we in economics we always need stylized assumptions, and assuming that something is common knowledge, it's a stylized assumption that's going to be useful for us in many situations. So we'll talk more about the empirical relevance in the next video. But yeah, this is common knowledge, and if you're interested, this was a concept that was conceived by a philosopher, David Lewis, in a beautiful book written in 1969 called Convention: A Philosophical Study. So if you find these things interesting, that's a wonderful read that I recommend to all of you. And with that note, we're going to stop this video. And in the next clip, we're going to talk about how we apply common knowledge, the notion of common knowledge, of rationality, to make predictions in games. See you next time.